Hello everyone, welcome back to Tech with Alok. We came back with another session. This is a session number 2. In the previous session we learned what Kubernetes is and why it was created. We also discovered that Kubernetes manages containers. But before learning Docker and the Kubernetes in depth, we first need to understand one very important concept. What is the difference between containers and the virtual machines? And more importantly, why did containers become so popular? So I promise by the end of this session you will understand why containers change modern application deployments. So without any further delay, let's get started. Let's start with a very simple real life example. Let's imagine you own a hotel and you have 3 guests which are coming to live inside it. In the option 1, let's consider you build separate villas for them, and for every guest you build one kitchen, one washroom and one bedroom. Let me start it in a way so that you would be understanding in a better. So own a hotel, let's say. All right. So the number 1 option is build separate villas. So in the separate villas, what amenities or what options that we have? Let's say we have one kitchen, one washroom, and one bedroom. So every guest is getting the complete isolation because the first guest will use its own separate villa. Second guest also receive the same thing. He would be having one washroom, one bedroom and one kitchen. So every guest is living in a different villa. You can say every guest gets the complete isolation. But we own some problems here. The owner of the hotel got high construction cost, more maintenance required, need in terms of maintaining the property, and more space consumption. So as owning a property in villas form, this is exactly how virtual machine works. Each virtual machines contain operating system. So in virtual machines, operating system, libraries, and application. So most of the time we can see in the virtual machines the things has been duplicated. So in the virtual machine 1 we have these many things. In the similar way, when we call to the virtual machine 2 and when we create a second virtual machine, then it also has a operating system, libraries and application. We have seen one real life example in terms of a guest living in a different villa and they have their own kitchen, washroom and bedroom. In result, the whole hotel owner maintained that property. Obviously, he will get the higher cost, higher rent against those property, but in terms of returns and in terms of everything, he has invested higher amount. The construction cost is quite higher than the single property. More maintenance is required and more space consumption is required. Let's see the another example in the similar way. Now let's understand the in terms of apartment. So now imagine an apartment. We have an apartment building and all residents share water supply. Let's say share so all residents shares water supply, electricity, building infrastructure. Building infrastructure. But with respect of the sharing of the common amenities, everyone has their own apartment. So in terms of apartment building, I would say shared infrastructure. There are some common items which is already shared, and every person is living in his own flat. So in the similar way, containers work exactly like apartments. Instead of carrying complete operating system every time, they share the host operating system, and because of that, it requires less memory, it requires less cost and faster startup time. Let's understand virtual machine architecture and let's understand how a virtual machine works. I'm providing one of the diagram directly here. All right, so we have this diagram. So we have to see virtual machine architecture. Okay, so we have to see the virtual machine architecture. So in the virtual machine architecture, what we have here, we have this physical server, hypervisor, and then we have a number of virtual machine, and each virtual machine is having the guest operating system applications, and similarly in virtual machine 2 and virtual machine 3. So what the purpose of hypervisor here is, so a hypervisor allows multiple virtual machines to run on a single physical server. We have many examples, like we have many hypervisors available in the market. Some of them I'm highlighting here: VMware, ESXi, Hyper-V, VirtualBox. So these are the hypervisors. So what we need to do, we have a physical, so whenever we need a physical server, or whenever we would be having a physical server, we will install these softwares which will allow us to deploy multiple VMs, multiple virtual machines on the top of one physical server. Let's say virtual machine 1 having application and guest operating system as an Ubuntu. Virtual machine 2 having the another operating system OS, CentOS, which is CentOS OS. And the third virtual machine, we have a Windows, plus we have an application in each virtual machine. So this is the complete architecture of virtual machine. If anyone asks you in interview, you can directly refer to this diagram or this flow diagram. But the problem with the virtual machines, let me write it here down here. The problems with the virtual machine. Number one is heavy weight. Problem number one is heavy weight. Suppose one of the operating system consume 2 GB of RAM. Another operating system consume another 2 GB of RAM, and another operating system consume another 2 GB of RAM. So in total, all the virtual machines can consume. So in total, virtual machines will consume 6 GBs of RAM in high memory consumption. So we are storing operating system 3 times, as we can see in the physical server. The second problem that we saw was a slow startup. So while booting up the virtual machines, let's see if we go one of the lab sessions. Definitely I will show you how the slow startup works in the physical server for a virtual machine. And sometimes it takes 1 minute, sometimes it can take 2 minutes and even more. The problem number 3, as we see in the diagram, as a real life example, we see it requires more maintenance and higher cost. So definitely in terms of maintaining the virtual machines, we would need a higher infrastructure cost. Higher infrastructure cost. Let's discuss about the containers here. In the containers, we would be having one physical server, a host operating system, that could be any one of them. We can install Ubuntu, either CentOS or Windows operating system. On the top of the operating system, we would be having Docker engine, and on the top of the Docker engines we would install many containers, or we can deploy many containers with a different set of images. This container can run different application, this container can run different application. The first container can run one set of application, the second container may run another set of applications. So containers don't need the different operating systems, and they don't carry their own operating systems. Instead, all containers shares the host operating system. Each container contains only, so this container having their own app plus libraries. Another container having the similar way, and the third container would be having its own app and another set of library which is required to run this application. So ultimately we get rid of the operating system in the containers. So it is not too bulky in the case of containers, but it is, let me explain. Containers don't carry their own operating system. Instead, all containers share the host operating system. Each container contains applications, library, and dependency. This makes the containers lightweight. sometimes we see or a question arises in front of us while giving the interviews or whenever we do a discussion, a technical discussion in the offices or other technical discussions or the communities, why developer loves container. So before the containers, developers say it works perfectly on my machine. The application was running perfectly on his machine, and whenever the same application goes on the production or the staging environment, the production team says it is failing on the server. Why it happens? It because the different set of different library different library versions, different dependencies, different environment. So the solution like containers. So in the containers, it packages everything all together. So the developer system is equivalent to the testing system or the testing servers and the production servers. So in each way or environments, we can say environment became consistent. This is one of the biggest reason containers became popular. Let's do a comparison. Let's do a comparison table between the virtual machines and the containers. At the first place, we will be highlighting the features. In the second column, we will take the features from the virtual machine perspective. And in the third column, we would be taking the features from the container perspective. Okay, at the first feature, we can take it as a startup time. And the second feature, we can take it as a size. Let me write it down all the features at the first place. The operating system, the memory usage, the performance, scaling, and portability. Let's consider the all features in virtual machine and the container simultaneously. So if we talk about the startup time, so we already understood this method. In virtual machines, it takes minutes of time. So it takes minutes, whereas in container it takes seconds. I will this concept will more clear for you whenever we'll be doing the lab. So very soon we would be jumping directly onto the lab sessions, and before that I'm just going on to the theoretical sessions. Just understand a bit so that you can relate in a better way whenever we'll be doing on the lab. The size, if I talk about the size from the virtual machine perspective, so the size would be large, and the size of the container small. An operating system, if I talk about, it requires a separate operating system. And in the containers, we don't need the separate operating system, so it works on the shared operating system. We just saw an example above. It has the host operating system, which is the shared operating system. Memory usage, if I talk about, so we talked about the memory If one of the VMs is taking 2 GBs of RAM, the second VM is taking another 2 GBs of RAM, and it's same goes on to the another VM. So in total it would be taking up 6 GBs of RAM. So memory usage perspective, it would be high, and in the container perspective, it would be low. Performance, I would say the performance is good until unless a VM crashes. So we can definitely say the virtual machine has an edge from the performance perspective. Here we can say fine or better. If we go on the scaling perspective, in the last session we already have gone through, whenever we need to scale up the virtual machine, we need more time and it is difficult to scaling. So we would say this is slow in scaling and this is faster in scaling. Portability perspective, we understood last time we can ship our application from one platform to another platform very not in a feasible way when we will be having the application in the virtual machine. So we would say moderate, and here we have the excellent portability. So this is the comparison table between the virtual machine and the containers. Please go through whenever you'll be watching this video. This is very important whenever you going for the interview sessions or you are understanding the concept between the virtual machines and the containers. So with all the comparison, what is the conclusion? Can we say the virtual machines are bad and containers are good? This does not mean virtual machines are bad. Even today, we use virtual machines in our applications. We have many cloud platforms like AWS, EC2, Azure virtual machines, Google compute engines are heavily used. Containers simply solve different problem and help us to manage the application in a better way. So why the container changed everything? Why containers changed? So we understood the concept between the virtual machines and the containers. So how we can say why the containers changed everything? Because using the containers, we can say our application is lightweight, portable, fast, efficient, and easy to scale. If the business does not require these number of features and he does not have any problem related to the application, or he does not have or he can manage the downtime and he does not need to take care about the lightweight or heavyweight, obviously we can go with a virtual machine for them. In today's world, we have a modern technologies like Kubernetes, OpenShift, Amazon EKS, Azure EKS, and Google GKA. So these are the platforms uses the containers, and all platforms are rely directly on the containers. Without containers, Kubernetes would never exist. So let's recap again what we learned today. We learned about the virtual machines, what are virtual machines, what are containers, why containers are lightweighted, Why developers love containers, and why container changed modern application deployments. So we have solved many questions today. So today we learned what are virtual machines, what are containers, why containers are lightweight, why developers love containers, why containers change modern application deployments. So we have got the answer of each question. With that, I think we are good with this session today. I hope you clearly understand the difference between the containers and the virtual machine. This is the one of the most important question that we see in most of the exams, and if you're preparing for the exam perspective or if you are preparing from the interview perspective, this is the one of the most important question that may come in your interview. In the next session, we will answer another important question: what is Docker and why do we need Dockers? I hope you now clearly understand the difference between containers and the virtual machine and why containers change modern application deployments. If you enjoyed this video, please hit the like button and subscribe to Tech with Alok. Also, let me know in the comments where you are watching from and what topics you would like to see on this channel. Session we will learn what is Docker, why do we need Docker. Thank you for watching, and I will see you in the next session.